Hi, this is Mr. Secoder here. In this video, I'm going to discuss a solution to a code force around 644 division 3. It's a problem G, name it AB matrix. This round 644 is under division 3, which is pretty easy, and but the last two problems seems to be interesting, that is problem G and H. So I'd like to make a video on these two problems. In this video we'll discuss problem G, that is AB matrix. So first let's see the question and then we'll dive into a approach of how to solve this problem. You're given four positive integers n, m, a, b. N is a number of rows, m is a number of columns, and a is exactly how many number of ones should be present in each row, and b is how many exactly ones should present in each column. So what it means is in each row you should have exactly a ones, and each column you should have exactly b ones. You should print whether that is possible or not. If not possible, you print no. If possible, you print yes, and you also print the matrix that is possible. Okay, so that is case 1000 and n is pretty small, n and m. So let's see the let's see example for how to approach this problem. I'll take this example from given question itself. So you think in this way, instead of thinking how to build this matrix, you will think how to avoid some of the cases, like all the no cases, how to avoid all the no cases. So one thing is clear, that if each matrix, if you look at rows perspective, there are total of n rows, right? So if you think in rows perspective, every row would contain a ones. Okay, each row should contain a ones. Like that, you have a total of n rows. Total of ones in this matrix should be n into this a, right? Yeah. So let's look at column perspective. Each column should contains exactly b, right? b ones. So you have m columns, so total number of ones in this matrix should be n into m into this b. So this should be same. If this is not same, this matrix is not possible, so you can directly print this is not possible, that is no. So let's consider this only case that you need to check whether it's not possible. If they are equal, then you can say you can form a matrix. So and now let's see how to build this matrix. So you, in the first idea that comes to my mind maybe is why can't we fill from left to right all the rows? So we'll try, but that doesn't work. I'll show you example. Let's say this matrix. So initially, let's say all have zeros. This has 5 rows and 5 columns, and each row should consist of 2 ones, and each column should consist of 2 ones. Okay, let's say what you are thinking is let's fill this with 1 and fill this with 1. Since row consists of 2 ones, 2 ones are filled in this row. So let's go to the next row. Check whether this column has 2. No, there is only 1, so I can fill 1 here. And then you check here, yeah, I can fill here. So this row is completed because you already have 2. Then you go to the next row. Since this column already have 2, this column already have 2 ones. So now we come to this column and see, like you don't have any ones here, so you fill 1, and then go to the next column and fill 1, and then there is this. Now you have 2 ones in this row, so you go to the next row and see, yeah, this is filled up, this column is filled up. This column has already 1, you can fill 1 more, so you'll fill 1 here. This column has 1, you can fill 1 more, so you'll have 2 filled in this row. Now come to the next row and you try to fill here, but there are already 2 ones in this column. Similarly, in this column you have to, this column you have to, this column also you have to. No, you can't fill in any of these columns. You can fill here, but the condition is failed, because this row, these all these four rows, contains two ones, but the last row contains only one, but it should contain two ones. So this logic won't work. So how to think is, you need to spread these ones evenly. Now you're spreading this one depending on how many ones you have. So but you have to fill this evenly, irrespective of how many ones you have in this column, until this column is filled. So our strategy is, like, you can do this in two ways: either keeping track of how many you have filled till now in some array called column count, in which you save all the column ones that you have till now, and then you can pick smaller of this and you can fill one there, and then you can sort that. You can do that. But there's also other approach, easy approach, that you can cycle through each of the column. Let's say first you'll fill one here in this specific row until you complete this a number of ones, that is here 2, right? So you'll fill 2 rows here, 2 columns here, and then a is so you have already filled this row with 2s. You go to the next row. Instead of filling from first, you fill from the next column that was filled before. Okay, now you got 2 ones in this row, so you go to the next row and then you fill. Whenever you reach at the end of these columns, you again cycle through the first column. Okay, so you'll come to here and then fill one. So wait, you haven't filled this, you haven't completed this row yet, right? So what you do is you complete here in this row itself. Now you have 2 ones in this specific row. Then you come to the next row and then continue from the column that you are left, this one. Okay, now you fill this column and you again go to the next and fill these 2 columns. Now you have spreaded the ones evenly across among all the columns, and now you can check, this row contains 2, this row contains 2, this row contains 2 ones, this row contains 2 ones, this row contains 2 ones. Similarly, all the columns also consist of 2 ones. So this is our approach. This is a easy approach that you can follow. Now let's look at the code. The code is pretty easy to code. So yeah, this is the code. What I'm doing is I have written some function which can read this n, m and a, b value. You need not care about all these templates and all these declarations, all these constants. You need not care about all these things. Just look at the logic in this solve function. I have declared a matrix of n by m, and I check the condition whether n into a is not equal to m into b. If that's not the case, then you have no solution, then you print no. If that's not the case, you'll have solution and print yes. So initially this for n is actually hash defined to, for simplification, this iterates over is equal to 0 to n. Okay, so you iterate over all the rows and columns and fill all the matrix with zeros here. Now we'll try to evenly distribute this NA, whatever the total number of A's that you're filling is, NA, right? You distribute all these NA ones among all the columns. So what this count is how many ones that you have filled not till now, because that will be helpful for filling the column cyclic way like this. So you iterate for all the rows, and each row you have to print exactly a ones, right? So in each row should contain exactly a one. So you increment this row count, and in every iteration of it you will fill 1. So that's why I'm increasing this 1 count also. So, and the thing to note is you need to go in a cyclic fashion, right? One trick to go in this way is whenever you reach at the end somewhere here, right? Sorry, let me take this. Okay, whenever you reach it this position here, what you do is you can mod this, you can mod with m, so that this position will come here. Okay, so when you, this row is the same, and column, for column you mod the number of ones that you have, so that will give you the correct column you need to fill with. So you'll fill that with 1 and then you just print it. So this is our solution to this problem AB matrix, and I hope you enjoy this video. Don't forget to like, share and subscribe to this channel and hit that bell icon to get notifications whenever I upload a video. I'm trying to upload new videos related to the contest as soon as possible when I have time, so stay tuned. Bye bye.